This conversation is powered by Google Illuminate. Check out illuminate.google.com for more.
We're diving into something really cool in genomic research, a new metagenomic foundation model called METAGENE-1. It's trained on a massive data set of wastewater samples, which is kind of unusual, right?
Yeah, unusual, but super powerful. The sheer amount and variety of genetic stuff in wastewater gives us a unique look at the human microbiome and, potential pathogens.
So instead of looking at single genomes, this model looks at the whole ecosystem.
Exactly. It's like going from studying individual trees to seeing the whole forest.
And what are we seeing from this forest approach?
Amazing results. The paper shows state-of-the-art performance on several benchmarks, especially pathogen detection.
Let's talk about the pathogen detection experiments. What made this approach so successful?
The variety in the training data is key. METAGENE-1 has seen way more genetic sequences than models trained on smaller data sets. This helps it adapt better to new pathogens it hasn't seen before.
So it's less likely to miss something unexpected? Exactly. Its ability to spot pathogens from different sequencing methods, even with limited training data, is a big deal. It's like having a super experienced detective who's seen everything.
And the MCC scores were impressive, right?
Yeah, way higher than other models across all four data sets. This shows it's a really robust and reliable method for pathogen detection.
The paper also mentions genomic embedding. Can you explain that?
Genomic embedding creates short, meaningful summaries of genetic sequences. These are crucial for building faster applications. Think of it like creating a really efficient index for a huge library.
So instead of analyzing the whole sequence every time, you use a summary.
Right, this makes analysis quicker and helps build lightweight predictive models. The results on the gene MTD benchmark were very promising.
And what about the human virus data sets?
METAGENE-1 totally outperformed other models, showing it's great at capturing important information for virus identification.
The GUE benchmark is a broader test. How did METAGENE-1 do?
It did really well, getting top scores on many tasks. This shows its potential as a general-purpose foundation model for genomics.
So it's not just good for wastewater, but also other genomic tasks.
That's the exciting part. While it was great at epigenetic marks prediction, it could be better at promoter detection. This shows how important it is to tailor the training data to specific tasks.
So the data set affects the model's strengths and weaknesses?
Absolutely. It highlights the importance of data curation and how we can improve things by refining the data set.
The last experiment was on anomaly detection. What was the goal?
To show METAGENE-1's ability to identify out-of-distribution data, which is crucial for spotting unusual patterns in wastewater.
And how did it do at distinguishing metagenomic sequences from other data sources?
Really well. The results clearly separated metagenomic sequences from human, mouse genomes, and random sequences. This is promising for real-world anomaly detection.
So it can flag unusual genetic material in wastewater?
Yes, which is key for early pandemic detection and biosurveillance.
The paper also talks about safety. What are the potential risks?
Misuse is a big concern. A powerful model like this could be used to design new pathogens or synthetic genetic materials. This is a huge ethical issue.
How are the authors addressing these concerns?
They've thought about these risks and chose to make it open source. They believe the benefits for research and pandemic preparedness outweigh the risks, at least for now. They emphasize careful safety assessments for future models.
A responsible approach.
Absolutely. Transparency and responsible development are crucial.
What are some future research directions?
Understanding how the model works is crucial. We need to use techniques to understand how it makes predictions and improve its reliability.
So making the model more transparent and explainable?
Exactly. This is essential for building trust and ensuring responsible use. Creating a standard evaluation suite for metagenomic models is also important.
To ensure fair comparisons?
Precisely. This will help the field advance and lead to better metagenomic models.
This has been really insightful. METAGENE-1 is a big step forward in metagenomic research, offering powerful tools, but the ethical considerations around misuse need careful attention.
Absolutely. Responsible development and deployment are key. Open science and collaboration are essential.
Before we wrap up, I want to give a shout out to Jay Poole from Tech Frontiers YouTube for his great content on AI and technology. Check out his channel. And to our listeners, share your thoughts in the comments. Thanks for listening.